I'm Chris Murphy from Viavi Solutions, and I'd like to thank Ericsson for this invitation to speak to you today about our geolocation rApp. So I'd like to tell you a little bit about Viavi Solutions, what we do, and what is geolocation and why it's important, and what have we done with Ericsson as we've gone on this journey on the Ericsson Intelligent Automation Platform. And then how is geolocation leveraged to build a powerful platform for optimization and an rApp ecosystem. And then finally, we finish off with questions and answers. So just a little bit about Viavi. We're a US-based company, and we're, in a nutshell, about collecting data from communication networks, monitoring communication networks, optimizing and assuring those communication networks. And that's all the way from the lab through to the deployment and then the field operation of the networks. And we're looking at the industry and how it's changing, particularly where fiber is becoming so much more important to the industry in terms of delivering the transport networks, how innovations in RAN are taking place, the transitions towards Open RAN, which I think is an important topic for today's conversation, through to everything from the transition to 6G, through to the baking in of AI into the networks, where data becomes so important and is a cornerstone of what 6G is going to be about. So a little bit about geolocation. About 15 years ago, Viavi realized that we could use the data that's collected from the networks, that the measurements that the mobiles make, and we can use that to estimate the locations of those mobiles. So we take quite a rich granular feed from the networks, and along with associated configuration information, and we can estimate the locations of those mobiles, and then use that information quite profitably to drive optimization of the network, as well as some other use cases. So this gives us a much finer, much more granular view of the network than we do with things like performance measurements. So networks traditionally collect information about what's happening on each cell. You can have how many subscribers are using each cell, what's the distribution of performance on those cells. But it doesn't tell you anything about what's happening within the coverage area of that cell. And that can be quite diverse, and there can be areas of concentrated usage of the network and areas where there's less usage. There can be areas where the RF is performing really well, areas where there's interference, areas where there's poor coverage. All this will add together to result in a customer experience which is varied and it isn't captured by those high-level statistics. So what we have in the geolocation is an ability to take these individual measurements, geolocated measurements of the network, aggregate them together into the insights that are important for understanding your network, understanding where the performance is good, where there's demand, and what you need to do about improving it. So the insights that you have can drive a number of use cases. You can think about the categories of use case. The engineers themselves who are engineering the network, traditionally they found this a very valuable source of data to make their decisions about how to optimize performance, where to focus their attention, and where to invest in more capital, more coverage, for example. And it also allows you to understand the consumer behavior, the user behavior, and the monetization use cases come out of that. But I want to make the linkage to the Ericsson Intelligent Automation Platform, because there are many use cases which we found for the traditional networks, which will then overlay onto very valuable use cases, which will turbocharge the Ericsson Intelligent Automation Platform. And looking at these sorts of use cases, we've got, I mentioned the network optimization. So where do we need to put more capacity? We need to put more capacity in where the subscribers need it. We need to be able to optimize the performance. So we need to understand where is the performance poor, how do we reconfigure the network to deliver better performance for that particular location, whilst not compromising the performance for the other locations. Troubleshooting. So when problems occur, there can be failures in the network, there can be components can fail, there can be storm damage to the network, or birds can strike antennas and knock them out of alignment. Understanding your network with a very granular, very deep, intimate view of your network means you can quickly find those problems. you can customer care. As your customers are using the network, they are sometimes they're very high value customers and they have problems, so they call up customer care, and you want to be able to have an answer for them so you retain them as a customer. So all of these are, there's many use cases that we found for the traditional networks, and these are use cases which we believe are going to be important for driving the Ericsson automation platform as a key enabler for the intelligent networks of tomorrow. So Viavi's had a long history with Ericsson, well before Ericsson Intelligent Automation Platform, but when the platform was launched over 3 years ago, Viavi was there as one of the founding members of the ecosystem, and we've had a very rich relationship with Ericsson since then. We've watched the platform evolve, and we've also provided inputs in the Ericsson engineers into how the platform can be designed to support app developers. So as an app developer ourselves, we've been able to help to shape that and provide feedback and provide the insights to the engineers. We were also, I believe, the first partner to be able to onboard an application onto the EIAP. We did that back in nearly 3 years ago now. So that was an achievement, and very, very proud to achieve that. So that was before we launched it. We actually launched the geolocation app 2 years ago at MWC. And since then, we've then partnered together. One of the Ericsson's big tier 1 customers has adopted the EIAP, and we've been part of that because we also share them as a customer, and we all want to see EIAP succeed and have geolocation at its heart. And then finally, it's not just about geolocation for Viavi. We also have a rich geolocation optimization portfolio, which are also bringing to EIAP. And we want to be a full member of the ecosystem of partners that you have, and make sure that we can help to deliver that promise of the EIAP platform. So what is our geolocation rApp for the EIAP? Well, what we've done is we've taken something which existed outside of the platform initially, of course, because we developed it for 3G originally. We ported the geolocation to LTE and then 5G, and we've kept up with the different generations of the technology. So we needed to make that into a form factor that was suitable for the EIAP. So it's now a service which lives on the EIAP and uses the platform services of the EIAP. It's consuming the trace data and the data it needs to perform the geolocation, do the enrichment, and expose the analytics that are needed by the external applications, by the applications built by Viavi and also by the partners in the ecosystem. So that's been our focus with the development of late. So we see geolocation as a foundational app. It's not something which delivers an outcome in itself, but what it does is it helps those applications which are making changes to the network, making decisions about how to deliver a more optimal performance. It allows those apps to have more information, more pertinent information about the network. Where is it operating well? Where is there interference? Where's there poor coverage? And make those decisions based on the reality and the richness of the data. Everything is about data these days with machine learning. It has a lot of data, enriched data, to support the decisions that are made. So thinking about some use cases, here are just some use cases which are inspired by where geolocation is able to deliver a significant improvement. So thinking about the world's moving towards massive MIMO, grid of beams optimization is something that needs to take place. So understanding where your subscribers are located and concentrated and how the mobility patterns are means that you can make intelligent decisions about which grid of beam patterns is going to be most appropriate for serving that specific subscriber population in that particular cell, based on the locations of where they actually are. Traffic steering, you've got multiple layers in your network, and making intelligent decisions about these based on the characteristics of the subscribers who are using those different layers. So some layers will have particular good coverage in certain areas and less good in other areas. Understanding where your subscribers are and where they're concentrated and what options there are for moving them to different layers based on their locations and the characteristics of those different layers is a very powerful enabler for traffic steering use case. Also understanding the subscriber population, where are they located now, but also what are the trends? Where are they going to be located in the next minute, in the next 15 minutes, in the next hour? And how does that deviate from what you normally expect? So that means you can make preemptive decisions about how to balance the mobility, perform mobility load balancing and load balancing between different layers based on what's going to be happening, not just now, and not what's happened in the past, but what's going to happen in the future. And then coverage and capacity optimization. So making that balance of how big do we make each cell, how do we manage the overlap of coverage between neighboring cells. When you know what your subscribers are, where they're concentrated, where they're located, and what they're experiencing, what they're measuring in terms of the RF, it's a very powerful input into how the optimization can take place. So these are all use cases, or some of the use cases which are possible to deliver more powerfully, more optimally, more accurately using geolocation as an input. But this isn't an exhaustive list. So what is Viavi doing specifically? The geolocation exists on the EIAP as a foundational capability, which is there for the ecosystem of partners to use, for Ericsson developers who are building rApps, for third-party developers who are building rApps part of the ecosystem. But Viavi also has capability that we build on our geolocation. First of all, we've got our optimization application itself, and we've got what we call it's a intent-based multi-objective optimization. And we've got a very specific use case for detecting cross feeders. Cross feeders occur when the point of installation, the wrong antenna is connected to a particular radio, and it means that you have you don't understand your design does not match what's out in the field, and then decisions can be made based on that wrong information, and mistakes can be made in optimizing the network. So we have an application for detecting that. But what I'd like to do is focus on our optimization application for the Ericsson Intelligent Automation Platform. So it's based, at its heart is the geolocation, using the measurements made by mobiles in the network, which are geolocated, the measurements of the radio, what the signal strength, signal quality is at different locations, how this varies around the network is an input into optimization. So it's data-driven. It's based on a model of the network, which is able to predict what will happen if we changed parameters of that network. If we changed across a cluster of cells. Across a cluster of cells, you can have dozens or even hundreds of cells, and each of these have many parameters associated with them. Well, some of those parameters we can change, and we can change in a model so that we can evaluate the impact on the performance before we actually make changes in the network. And this is a very powerful approach, because it means that we can search the space of possible configurations, which is a very multidimensional space. There are very many possible configurations, and find those configurations which deliver the optimal performance according to the goals of the operator. So sometimes the goal can be delivering better capacity, sometimes it can be delivering better coverage, sometimes it can be focused on particular types of application or particular types of network usage. Whatever the goal of the operator is, that can be reflected in the optimization decisions that are made so that the ideal outcome for the operator is achieved. So we've delivered this optimization capability, and this is some results that we've delivered this in the field for the traditional vertically integrated networks, and as I say, we've now launched it for the EIAP. This is some simulation results we did based on some funding that we got from the UK government, and a project we did with the Telecom Infra project, of which Ericsson is now a member. And what we did was we simulated a network with, I think it was seven cell sites, and they were tri-sectored sites in general. And we had several hundred simulated mobiles. And what we did was we got the optimization, the data-driven geolocation-enabled optimization to make changes to the network and measure the performance improvements. And what we found was that we were trying to optimize for the interference, to drive out the interference whilst maintaining the other metrics. And using the RSRQ, the signal quality, as a proxy for the interference, we managed to shift the RSRQ significantly to the right after the optimization. And the result of that was that there was a better quality for the UEs using the network, and there was more capacity. You were able to support significantly more subscribers as a result of that. So that was something that was a good result that we were pleased with, and we're very proud to be able to bring that capability to EIAP and be part of the ecosystem with this. So just bringing this to a close, these are some key takeaways. So Viavi are the industry leaders in geolocation. It's not positioning, it's not using GPS, it's using the measurements that are available in the network to perform the geolocation, so we can locate all of the subscribers and use that information to derive various use cases, including in this case optimization. So what you're doing is you're then focusing your view of the network on the subscriber, not on the cell. So the subscriber ultimately is what's important, and what they achieve, what their service is, what their experience is of the network. And we're able to trade off the accuracy and the latency. We want to have a low latency estimate of the location, so we can drive fairly short-term decisions about how the network is optimized. So that's something which is important as we start to serve the ecosystem of the rApp providers. We're a proven technology because we're geolocating today. We're geolocating a billion subscribers on the various MNOs that we count as our customers. We have the rApp, which is part of the ecosystem, part of the EIAP platform, conformant to the standards expected, and using the platform services to deliver our capability. And it's bringing, in case of EIAP, the rApps, that ecosystem of partners can now leverage that power of that geolocation to deliver their intelligent decisions more accurately and with more impact for the network. And so that's in summary is what we're doing. A few more key points here. I won't go through those because I think I've covered it. But Ericsson has been a good partner for us, and we want to be part of that, a full part of that ecosystem, not just as a suite of rApps which deliver the changes, but also as a foundation for the whole ecosystem to use. So anyone who's interested in developing rApps or is developing rApps for the EIAP and wants to know more about the geolocation that we have as a foundational capability, we're very interested to talk to you and see how we can help you to deliver better changes with more performance improvements for the MNOs running EIAP. Thank you.